Hello everyone, this is Jyotsna. Welcome back to my YouTube channel. In this tutorial, we will see the concurrency and parallelism topic in our computer science and programming. So, what exactly these two topics are, how they are related, and how we use those topics in our software programming. Let's see that. First, start with concurrency. So, if we see the definition of concurrency, first see what is concurrent means. So concurrent means two or more things happening at the same time, means concurrently. So in software programming, concurrency is when two tasks can start, run and complete in the overlapping time period, and it doesn't necessarily mean that they will ever both be running at the same instance. Means tasks or processes are running concurrently, right? So concurrency can be broadly understood as multi-threading also. So we'll see next what exactly multi-threading, how we achieve it in concurrency. And again, concurrency can be achieved on a single core processor through context switching, where the processor rapidly switches between tasks, giving the illusion that they are running simultaneously. So concurrency is a design and structure issue, actually allowing tasks to overlap in the execution, right? So they are giving the illusion like they are running simultaneously, but actually they are running in the overlapping in the execution, right? So next, see, there are some of the techniques of concurrency. Three main techniques are given here. The first one is multitasking, then second one multi-threading, and then event-driven programming. So with multitasking, this involves the simultaneous execution of multiple tasks by a single processor. And here the processor switches between tasks based on the certain criteria, such as time slices or task priorities, allowing the multiple tasks to make progress concurrently. Then next is multi-threading. So this allows a single process to execute multiple threads of execution concurrently. And here each thread represents a separate flow of control within the process, allowing different parts of programming to be executed independently. The third one is event-driven programming. So this involves responding to events or messages asynchronously, allowing tasks to be executed in response to external stimuli. And this programming is commonly used in graphical user interface and network programming, right? So these are the three techniques of concurrency. Next is some of the basics of C sharp in concurrency. So in C sharp, we have different classes which are given for the multi-threading and multitasking. So let's see these two concepts in brief. I will give the example in our coming videos. I will explain these threads and tasks with example also. But with this video, we will just explain it theoretically. So let's see what is the thread concepts in concurrency, right? So threads are the fundamental unit of execution in concurrent programming. This is the definition. So in C sharp, we have a thread class under system.threading, which allows you to create and manage threads. And to create a new thread, we can create object of this thread class, and we can pass a delegate representing the method to be executed on this new thread. So to this object of this thread class. And threads can be in one or several states. So these are some of the states of threads which we can use while using concurrency threads in our programming. So unstarted, running, wait, sleep, join, suspended, stopped, and aborted. These are the some of the states of thread. Also, if you want to check the state of thread, we can use the thread state property. So thread have this property using which we can check which state in which thread is currently. And also, if you want to give the priority of threads for the execution, we can use this priority property. So these are some of the properties of thread. Next is task. So task in C sharps are a high level abstraction for concurrent programming built on the top of threads. So we have a task class in our system.threading.task, which represents a single operation that can run concurrently and return a result. So tasks are more lightweight and flexible than threads, and they integrate with async and await keywords for asynchronous programming. So these keywords are also very important. I will explain this with example in our coming videos. So with task, we can create a new task using task.run or task.factory.startNew methods. These two are methods under task class which we can use to create a new task, right? And if you want to cancel the task, we have another classes task cancellation token. So source and cancellation token. These classes we can use for the task cancellation. And for task continuation, we can use continue with method to specify new task that will start when the previous task completes, right? So these are some of the basics of threads and tasks in C Sharp. So that was about the concurrency, different techniques, and some of the basics of concurrency. Now see what exactly parallelism is. So definition for the parallelism: execution of multiple tasks simultaneously. So if you see parallelism, name itself says what exactly it is. We can run the multiple tasks simultaneously using parallelism concept. So parallelism is a subset of concurrency, but not all concurrent systems are parallelism. So it's a subset of concurrency. So simultaneous execution of multiple tasks or processes to achieve the faster results, we can use parallelism concept here. So parallelism is based on the idea of dividing a task into smaller subtasks, and that can be executed concurrently on multiple processing units such as CPU cores or distributed computing nodes. So this is very important. So with parallelism, we are dividing the task into smaller subtasks and are executing those concurrently on different CPU cores or distributed computing nodes, right? And in C Sharp, it offers one class in our system.threading.task, which is parallel class for the parallel execution of task. And this simplifies the process of creating and managing parallel loops and operation. So this is the introduction about parallelism. Let's see the techniques of parallelism. So parallelism also have three techniques: instruction level parallelism, task parallelism, and data parallelism. So what is instruction level parallelism? So this parallelism involves execution of multiple instructions from a single program simultaneously. And in the modern processors, we use these techniques such as pipelining and superscalar execution to achieve the instruction level parallelism, right? So in task parallelism, this involves the dividing a task, as a name suggests, it into a smaller subtask and can be executed concurrently. Each subtask is typically independent and can be executed on a separate processing unit. So third is data parallelism. So this involves the dividing a data set into a smaller segments and processing each segment concurrently. And data parallelism is commonly used in parallel processing frameworks such as MapReduce or Hadoop. So these are the three techniques of parallelism. Next, see the some of the C# basics which we have for the parallelism. So in C Sharp, we have different methods for the parallelism. First one is Parallel.For and then Parallel.ForEach. These two methods are are used to enable execution of parallel loops in C Sharp. So Parallel.For operates on a range of integers, while Parallel.ForEach operates on a collection of items, that is list and array. The choice between these two methods depends on a specific structure of your data and the loop requirement, right? And if you want to cancel the parallelism or handle the exception, we have the different objects like parallel loop state object and parallel option class we can use in parallelism, right? So there is another method like Parallel.Invoke, which allows you to execute multiple actions in parallel. So to handle cancellation and exception with Parallel.Invoke, use the parallel option class. This class we can use for the exception handling or cancellation of parallel task, right? So next is the difference between concurrency and parallelism. So there are different aspects in which these two concepts are different, but actually they are similar. So parallelism, as I said, is a subset of concurrency. Not all concurrent systems are parallelism, but parallelism can be concurrent, right? So the first aspect of difference is definition. So how they are different? Um, with concurrency, we handle multiple tasks simultaneously, and here we are using interlude execution, right? So means if you have any design or structure issue where we are allowing the task to overlap in execution, that time we use concurrency concept, right? And with parallelism, we are executing the doing the simultaneous execution of multiple tasks, right? So next aspect is execution, how the execution are differing in both concurrency and parallelism. So in current concurrency, we have tasks which are may not actually run at the same time. Oh, they are overlapping, not running at the same, may not running at the same time. And with parallelism, tasks run at the same time, utilizing multiple processing unit, right? So in terms of performance, concurrency improves responsiveness and resource utilization, while parallelism improves performance and throughput. So one of the example for concurrency is multi-threading in a single core process, CPU, right? And in parallelism, for parallelism, the example is multi-core CPU or distributed computing. The focus of concurrency is task management and scheduling, while the focus of parallelism is task decomposition and execution. And the goal we use concurrency concept is for the efficiently utilize CPU time and resources, while for the parallelism we use for the speed of up execution of task. So which concept we can use in our software design, concurrency or parallelism? It's wholly depend on your the way your system works and how you want to achieve the particular aspects for that software design, like how we want the performance or execution or goal of our software, right? Based on that we can use this parallelism or concurrent concept in our application designing or programming, right? So this was the some of the introduction of concurrency and parallelism topic, which is actually very important in terms of performance of our system, how we can design or how we can program our system using this concurrency or parallelism execution. So we'll get very which improves the responsiveness or improves the performance of our system. So it's a very widely used concepts. In our next video, I will show how we can use this C# basics in our examples, right? So these threads and tasks will give some examples where we can use the different properties of thread and task class, and how we can achieve the performance of our system using this basics of concurrency. So for this video, this is all from my side. Thank you so much for watching.